Okay, so for the second part of section 1.2, we're going to talk about scientific notation. Okay, so scientific notation is a convenient way to write really big or really small numbers. Okay, that's all it's about. So, in general, what do these things look like? Well, let me leave some blanks. So, something, point, something. This has to be one digit. This could be 1, 2, 3, doesn't matter, digits. Times 10 to some power, okay, some power. So that times 10 to the some power is necessary for it to be scientific notation. Okay, so now some things to keep in mind. The bigger this number, right, the bigger this number, the bigger the exponent, the bigger the value. Oops. The value or the number. Okay, and when I say bigger, what I'm referring to is not necessarily in like grand scheme of things, right? Because technically 1 is bigger than -1, right? Or -10. 1 is bigger than -100, right? That's not what I mean. I mean in magnitude. So if I say 100 or -1 billion, that -1 billion is bigger than the positive 100. Okay, that's what I mean. Okay, so the bigger the exponent, the bigger the number. And of course, in reverse, the smaller the exponent, the smaller the number. Okay, so keep that in mind. Also, important to know, positive exponent equals big number. I know, really simplifying this thing. Positive number gives you a big number, or positive exponent gives you a big number. A negative exponent will give you a small number, a decimal. Okay, so that's the main ideas that you need to keep in mind. Okay, positive, big, negative, small. Okay, so for example, right, let's get to some examples here. Let's write 7.43 times 10 to the 6th in standard form, standard notation. Okay, so first of all, this is a positive number, right? So we're looking at a big value, okay? Something in the millions or so, right? 10 to the 6th means like a million, okay? If it were negative, then we'd be looking at a very small decimal. Well, okay, so how do I actually write out my answer? The easiest thing to do is to write out the 7.43. Maybe don't write the point, but like, that's where the point is. Just know where it was. And then say, okay, I have to make this a big number. Well, I have to move this decimal. I can move it this way, or I can move it that way. If I move it to the left, I end up with a really small number, point something. But if I move it to the right 6 times, I end up with 7, 4, 3, put some zeros to fill in those blanks. I like to put little scoops because then I can put zeros in those scoops. Okay, and that moves a decimal. So that gives me 743 with 4 zeros. In other words, that's 7,430,000. A big number, right? What about 7.43 times 10 to the negative 6th? Okay, start off with the same idea. Decimal is here, but go this way 6 times and put some zeros in the little scoops. So what number is that? That's a small number, point 1, 2, 3, 4, 5, 7, 4, 3, right? 1, 2, 3, 4, 5 zeros, and then the 3 digits that were given. Okay, so point 0.00000000743. That was hard to say. Okay, a very small number, right? You could put the 0 in the front if you want to, although it's not necessary. Okay. What about 9.4 times 10 to the negative sixth. Let's change that up. Let's go negative fourth, just so we can have something different. Okay, well, 9.4. I have to decide if I'm moving the decimal to the right or to the left. If I'm trying to make a small number because that negative, then I have to go to the left. 1, 2, 3, 4. Put zeros in the blank. So 0.00094. Put that 0 in the front there. I like the 0 in the front. Okay, so I wrote these numbers from scientific notation to standard notation. What about this? Negative 6.019 times 10 to the eighth. I see a negative, right? But that negative is not going to tell me if this is a big or a small number, right? That's the exponent's job. The exponent is positive, so I'm expecting a big number here. Big number means move the decimal this way. 1, 2, 3, 4, 5, 6, 7, 8. And put some zeros in the blanks. Oh man, let's see. That's one. Boom. That's 601,900,000. Okay, let's go the other way with these. Let's say I give you a big or small number and you need to write it in scientific notation. So let's start off with 3,230,000. Okay, so first of all, you have to imagine where that decimal is located, right? And we would say the decimal is located here. Okay, if you don't see it, that's where it's located. All right, so let's look at the digits. 3, 2, 3, and then the rest are zeros. So we ignore those zeros. We just put the 323. 3.23 times 10. And then I count. This decimal is here. It needs to be located here. How many numbers are in between? 1, 2, 3, 4, 5, 6. So this is a 6. Now the question is it a positive 6 or a negative 6? Well, the original number was a very big number, so I need it to be a positive. Okay, example 7. Negative 35,000. Okay, scientific notation says I have to have the number 3.5, right? So I got to put a decimal here. It's already located there. That is 1, 2, 3, 4 spaces over. So is it a positive 4 or a negative 4? Negative 35,000 is not a decimal. It's a big number, right? Big in magnitude. Again, let me emphasize that. So there we go. Negative 3.5 times 10 to the fourth. Okay, let me scroll on down. Example 8, we have 0.000367. Okay, there's my decimal this time. This is a small number, right? So I'm expecting a negative exponent here. Okay, what are the non-zero digits, right? So I'm looking, ignoring all these zeros until I hit my first number that's not a 0. That's a 3. And then the numbers that come after it. So that would be 3.67 times 10. Okay, I want the decimal to be here. It's currently located here. That's 1, 2, 3, 4 spaces over, 4 numbers. So I'm going to put in a 4. And I said it's a negative 4 because, again, the original value was a negative. I'm sorry, not a negative. The original value was a small number. So I need a negative exponent. Okay, negative exponent, small number. Okay, here's a weird looking one. What's this, 9? What about 521? feel like I skipped a number here. I sure did. I skipped example 6. Turns out I actually didn't skip anything. It's just the numbers are off. Something wasn't adding up. I know I could have let that go, or I can go back and fix it. So I fixed it. Okay, example 8. All right, so 521. Okay. Well, 5.21, right? The decimal's there. We need it to be there. I don't have any zeros. That's the weird part about this problem, but it's okay. Times 10 to the, okay, how many numbers in between? 2. Now, would you say 521 is a big number or a small number? Again, our small numbers are going to be like 0.003, right? Our big numbers are pretty much anything bigger than 1, really. So 5.21 times 10 to the positive second power. Positive because 521 is a bigger number. Now, again, notice this second power is a lot smaller than, let's say, this sixth power, right? Well, that's why this one's only 500 and something, and this is 3 million and something, right? That exponent, the bigger the exponent, go back to the beginning, right? The bigger the exponent, the bigger the number. Okay. 2 more examples. And these are really just some, I guess, applications of scientific notation at this point. Maybe not application problem isn't a word problem, but this is just some, these are tricky problems. Let's just say it like that. All right, so 5 times 10 to the negative 4th times 9 times 10 to the 10th power. Okay, so this question, we want to figure out this problem, right? We want to multiply it out and everything. And then from there, we want to write it in scientific notation. And that's where it gets tricky. Okay, so first things first. To take care of this kind of problem, do this first. Multiply those first numbers together. 5 times 9. Okay. 5 times 9 is 45. Now, go back to your laws of exponents. Let's ignore all this. Right? Well, I can leave that. If I ignored that and just focused on those two things, I can put those two 10s together and add my exponents together. Right? So negative 4 plus 10 is a positive 6. Okay, so 45 times 10 to the 6th. Now, this is not in official scientific notation, right? You're supposed to have a decimal right here, but instead it's right here. Okay, so let's think about that for a second. What do I do about that? Okay, well, I need the decimal to be here, which means I need to change this to either a 5 or a 7, right? I have to change that by 1, right? That's kind of how we move the decimal, by changing the exponent. Okay, so the question is, what is it going to be? Well, I would say that I need 4.5 times 10 to the something. Well, compare 4.5 to the original. Is the original compared to the small one, right? These two comparatively, is the red one, 45, bigger or smaller? It's bigger, right? It's bigger. So I need to make my new exponent bigger. Okay, that bigger exponent is going to compensate for the fact that this was made, or this one was made smaller, right? I made it smaller, but I accounted for it by changing my exponent, making it bigger. Okay, let's do one more like that. And let's make sure we really got it. So 5 times 10 to the negative 6th times 4.9 times 10 to the negative 8th times 4 times 10 to the negative 10th. Good golly, Miss Molly. Okay, so 5 times 4.9 times 4 actually comes out to 98. You could use a calculator, or you can think about that for a while. 98 times 10 to the, okay, negative 6 minus 8 is negative 14, minus 10 is negative 24. That's a really small number, right? But hold on. needs to be 9.8 times 10 to negative something, right? So the question now becomes, let's compare these two. 9.8 and 98. In order to go from here to here, I made the number in the front smaller, right? 98 turned into 9.8. I made it smaller. I need to compensate for the fact that I made it smaller. So that means I need to make my exponent bigger. Make my exponent bigger. Okay? I need to make it more positive. So I'm going to add 1 to the exponent. Negative 24 plus 1 is a negative 23. So there is my answer in scientific notation. Okay? Again, let me rephrase this. 9.8, where the original was 98. Okay? Which means that I needed a number for my exponent that was bigger, and not bigger in magnitude, but bigger on like the scale, right? If you think about the real number line, I needed a number that was a little bit less negative than negative 24 to compensate for the fact that I made this number smaller. And so I added 1 to make it negative 23. Now, before I go and wrap this up, what if I wanted to make it even smaller, right? This is technically not scientific notation, but let's say I made it even smaller. Okay, I got to compensate for that, so I will just add another 1 to the exponent, and so on. Okay, anyway, let me erase that. That's unnecessary. Okay, so that's scientific notation.